Yeah, so today we'll discuss about Citrix MCS. Okay, so MCS stands for Mission Creation Services. In the Citrix XenDesktop, in Citrix XenDesktop 4 and 4 point some 5 PVS is there for the imaging. But from XenDesktop 5 onwards, Citrix has introduced MCS. Citrix has introduced MCS. Prior to that only we have PVS. Now what we have? Both PVS and MCS. Okay, in in XenDesktop 5 and 5.6. XenDesktop, the last version is 5 and 5.6. Okay, so in XenDesktop 5 and 5.6, what happened is we have both PVS and MCS. Okay, so then in XenApp 6 and 6.5, or maybe 5, 6 and 6.5, we don't have MCS. Okay, so that means if we want 1000 XenApp servers, what we need to do is we used to create only through the PBS is only the imaging solution we have. If we want hundreds of XenApp servers. From 7.x, what happened is MCS is supported for server OS and desktop OS also. That means VD on multi-session OS or single session OS. MCS is supporting both. MCS is supporting is both. Say here a server multi-session OS is nothing but is a XenApp kind of features. Single session features are nothing but desktop kind of experience. Now MCS from the 7.x, yeah, so from 7.x what happens?
MCS is introduced for both the applications and desktops.
Yeah, not applications, so single session OS and multi-session OS. Okay, so that's is nothing but it's both XenApp and XenDesktop also technically is supporting MCS. Previously for XenApp 6 and 6.5 we don't have MCS kind of imaging. Okay, so in the large scale environments they can use PVS itself. But now in 7.x PVS is supported or not? In
Yes,
7.x
sir.
also PVS also supported. PVS is also is supported. Okay, so now here if you go for MCS, as what is the meaning of MCS? Mission Creation Services. Mission Creation Services. Okay, on behalf of us, if we want 1000 missions also, those missions have been created by controller. Okay, so controller creating missions using hypervisor or cloud capabilities. Okay, so controller is creating the missions using hypervisor or cloud capabilities. If you go for PVS, so we have a Citrix PVS, another streaming technology is there. Okay, so we have two important technologies behind the Citrix now for the imaging purpose. Okay, so what is the meaning of imaging is I want 1000 desktops. I no need to create 1000 desktops. I no need to create one image. I'm going to create. Okay, that itself is going to be created into thousands of desktops from the same image. Okay, for the imaging, what are the types of technologies we have in the Citrix now? So, what are the types of technologies we have?
PVS.
Yeah,
MCS.
PVS, MCS. both have their own advantages, disadvantages. Okay, so as a Citrix admin, we should have the knowledge on both. Okay, previously we have more MCS, sorry, PVS kind of projects we have, but now we have most of them are moving to MCS. So 30% we have PVS, 70% we have MCS, and a lot of projects having mixed also. That means some desktops have been created through PVS, some desktops have been created through MCS. Okay, so now MCS is one of the provisioning technology with the Citrix virtual apps and desktops that allows rapid creation of virtual machines using a single master image. Okay, so now here what is the main advantage of PVS and the images? Okay, single image management. Single image management. Okay, so what is that meaning is you want to create or you want to update, you want to roll back or roll out. Okay, you want to revert back or roll back. Okay, so then only one image is enough. If you have the 1,000 desktops, if you want to upgrade to the patch levels or higher version, then 1,000 times you need to do it. But if I go for a PBS or MCS kind of technologies, only one time we are going to do that. Only one time we are going to do that. Okay, so that kind of single image management is possible with both PBS and MCS. So what is your understanding of single image management? What is your understanding of single image management? So you want to create hundreds or thousands of desktops. Only one time you need to create the resources. Create, update, rollback, deletion. Okay, so all those also can be done with the single image management. So that is the advantage to go for MCS. Okay, so MCS is a very simple kind of virtual desktop, and compared to PVS, MCS is very simple technology. Okay, so now here in the MCS architecture, that single image we need to prepare. That single image is called as a master image. Okay, other than master image, we have one more term we can use in this, that's called as golden template. Okay, so here for the master image itself, there is one more terminology that is called as golden template. So that is called as golden template. So what is the concept of the golden template is like if you want the 1,000 missions, so assume my company want to give Windows 11 to the users. Then in those Windows 11, we need to create the patch levels. So what is the antivirus we want to give? Okay, so then we have the global infrastructure security patches. All these we need to make sure according to our company standards. So our company will have the standards, what are the best practices we need to follow, naming patterns we need to follow, how to install the applications. Okay, so what are the logos we need to set, all that we need to set up on the desktop, and it need to join to the domain, up to date patching, up to date antivirus, GAS patches. Okay, so what are the applications we need to install. Okay, instead of installing the applications, the another method is those applications can be delivered even from the multi-session OS also. Okay, if you want to deliver the applications from the multi-session OS on the desktop, what we need to install? On the desktop, what we need to install?
VDA.
No, no. VDA anyhow we need to install. Additionally, we need to install Workspace app also. So that Workspace app is going to receive the applications from the multi-session OS. Means we are not installing applications on the desktop or master image. Okay, so then applications optionally I'll called as Workspace app. And from the VMware wise, we have one mandatory tool. What is that? From VMware wise,
Citrix receiver.
no, VMware tools also are mandatory. Okay, so VMware tools also is mandatory. Okay, so then patching, up to date patching, antivirus, GS patches, applications, workspace app. Okay, so these if you take, okay, if you want the server class, you'll take a multi-session OS. On that also will have the VMware tools, patches, antivirus. Okay, so then here after patches, antivirus, GS patches, I recommend to go for VDA. Okay, I recommend to go for the VDA. Then at this moment, we need to take the snapshot. That snapshot is called as master image or golden template. That snapshot is called as master image or that snapshot is called as master image or
Golden image
golden template we can call. Okay, so master image or golden
template.
template. Okay, so then the master image is having the operating systems, applications, all your configurations. Okay, we need to optimize lot of settings on your master image. Then our job is very cool and it will consume less resources on the hypervisor and networking also. Up to date patching also is very, very important. Okay, so then any updates or changes need to be performed on the image. Okay, need to be uh, perform with the lot of care. Okay, and we require a lot of monitoring, some kind of testing also in the staging environments required. Okay, so once we create this the master image, if it's mandatory we need to take the snapshot. If you don't take the snapshot also, MCS itself will create the snapshots. But one of the best practice is always take the snapshot. Okay, then like snapshots are whenever you are creating the 100 catalogs or 1000 missions from that from the single master image, first it will take the snapshot at that point of time. Okay, so to create the VMs from that state, it is going to create the VMs. Okay, so full clone. What are the disk are going to come? Also, we'll discuss. So first, it will create a base disk. Okay, that the base disk is created from the snapshot of the master image. All those, say, suppose assume we are going to create 1000 missions in MCS. Okay, we are creating 1000 missions. Then can you guess how many base disk or parent disk are creating? Okay, the base disk is only one base disk is getting created for all 1000 missions also. If you have the 100 missions or 1000 missions also, the base disk is only one. The base disk is only one is getting created. Okay, then the second disk is for the 1000 disk, identity disk is the like a 1000 identity disk are getting created. Okay, 1000 identity disk are getting created. Okay, then delta disk or differential disk. Okay, so the differential disk also is going to create 1000. Okay, can you tell me if I create 100 desktops, how many base images or how many base disk are getting created?
One, one
Only one. How many identity disk are created?
thousand,
Yeah, in that use case 100. Okay, how many differential disk are created?
thousand,
Yeah, say if it is 100 differential disk. Okay, what is the size of this? My VM master image is 80. So my
80,
master image is 80. Then this one disk image also the size is 80. 80 GB assume. Okay,
twenty,
identity disk size is it's 16 MB. Okay, it's irrespective of. Okay, so only that Mac IDs, SIDs, host IDs, those all the identity kind of images are going to store in identity disk. That means even if the mission has been restarted, or if you shut down also, the MAC ID, all those details like host name, all these details are stored in identity disk. The differential disk is user data is going to be stored. That means I install some applications. The base image for the 1000 desktops also is same. Okay, but on top of that, if I install some applications, if I copy some files, all the data, my session data, all that, it's going to generate some temp data. All that is going to store in the differential disk. So that means some of the user data may goes to 2 GB. Some of them may take 10 GB. That depends upon their requirement. They are going to store the data. Okay, so based on that, that's going to store the data we are going to store. Okay, so these images are getting created. These images are going to, okay, so now here what is going to happen, we'll discuss. If I have 1000 desktops, okay, with 80 GB, 1000 desktops with 80 GB, how much space it takes? If I have the 1000 desktops with 80 GB, how much I want? So around 80 TB of the data I required. Okay, so then in this use case, if I use the 100, one is 80, then all that 1000 into 16 MB is also maximum one itself. And 1000 desktops have been using uh, 2 GB like this. Okay, then that's going to use only the 2 TB kind of data itself. Okay, so now here even if the user data is very less also, so that data in the differential disk, what is going to happen is once the user log off, the 2 GB data also is deleted. That's again comes to zero itself. Okay, so with the very less kind of data also, okay, storage wise, we are going to reduce 80 to 90% of the storage has been reduced by the MCS kind of catalogs. And provisioning is like only one time we are going to provision. Only one time we are going to provision. Okay, so like this here we have the lot of advantages. Okay, those we are going to use. Okay, so then already we know the mission catalogs, right? But for the MCS, while creating the mission catalogs, definitely we need to use MCS managed catalogs itself. We need to create, and after that we need to create the delivery groups. In the mission creation process, first we need to take the master image we need to create. Okay, then snapshot creation. If you don't create the snapshot, what is going to happen? If you don't have a snapshot, MCS itself will create the snapshot. MCS itself will create the snapshot. Then from that, we are going to create the provisioning of missions. Okay, say here while creating this the first base disk. If my first base disk is created for 3 to 4 minutes, if that first base disk has been created within the 3 to 4 minutes, okay, so remaining all that mission catalogs would be created in the first 1 minute itself. That means it no need to copy 1000 times. Only for the first base disk itself to create that it will take more time. After that, a small automation for each and everything the same base disk, a one identity disk of 16 MB is going to attach, a zero size delta disk or differential disk going to be attached. Once the user login and connects, and if we perform some data, that is going to be stored in the base image or base disk or differential disk, where the user data is going to store.
Differential disk.
In the differential disk, that data is going to be stored. Okay, and with the there are some of the pooled kind of catalogs. With the pooled catalogs, what's going to happen if the user shut down or like reset the desktop? What is going to happen with the pooled catalogs? the differential disk is going to be
Cleaned
0.
up.
Yeah, that differential disk will become again 0 itself. Okay, but with the dedicated catalogs, what is going to happen?
Data will store on desktop.
Yeah, the data is going to be persistent in the differential disk itself. Okay, so if I create a pooled catalog with MCS, what is going to happen? If I create a pooled catalogs, what is going to happen? The data is persistent. Okay, if I create a pool catalog, the differential disk is going to be deleted. Okay, what is the other name for differential disk we can call is delta disk. Okay, it's called as delta disk. Okay, so then with the dedicated catalogs, that is persistent. That means which catalogs will take more storage, pooled or dedicated? Pooled or dedicated, which one will take more storage?
Dedicated.
Yeah, dedicated will take more storage compared to pooled catalogs. Okay, so now here, what is the size of base image or base disk? What is that? What is the size? What is the size of the base disk? That size depends upon your master image. Your master image is having 100 GB. Okay, your base disk also is 100 GB. Okay, what is the size of differential disk? The size of the differential disk is what is the data or application data user is going to take. If the user copies more data, then delta size or differential disk size is more. That depends upon the user data, application settings, which of the applications he will install, what are the files he will copy. According to this size is increasing. Okay, what is the size of identity disk? Identity disk is only maximum 16 MB itself. Okay, each and every mission identity, like what is the host name, domain membership, SIDs, MAC IDs, all these details are going to store in the identity disk. Whenever we want to do the update or rollbacks also, the identity disk will give that these details to the desktop. Because user data differential disk is going to delete, right? Still, that mission required the identity. Those all the details we are going to store in. Those are the details we are storing in the identity disk. Those all the details are storing in identity disk. Okay. So now what are the use cases why we are going for mission creation catalogs by the VDA is rapid desktop deployment. Even 1,000 desktops also can be provisioned within a 5 to 10 minutes itself. In the physical infrastructure or in the virtual infrastructure, creating thousands of missions will take a lot of time to deliver. But with the MCS, what is the advantage is rapid desktop deployment is possible. Okay, so fastly we can deliver the desktops, and even we want like we have like non-persistent kind of desktops where we have task-based workers. They just need to work that, and we don't want any data. That kind of non-persistent VDA environments we can give, and say MCS catalogs are mostly the pooled catalogs or the cheapest catalogs. Okay, so both we can give applications and desktops also can be given to the users, and from the branch offices also they can connect. Okay, so we have a lot of advantages. Okay, with the MCS. Okay, so now the main advantage, first one is automatic provisioning, a single instance management. Thousands of missions, automatically we are creating. Otherwise, even 1,000 times cloning, all this manually doing is little challenging. Updates, rollbacks, deletion also at the catalog level itself we can manage. Okay, that's a single instance. Storage wise, okay, say we have 80% of that technology. So now the same technology in the VMware, it's called as a linked clone. Okay, that means all the 1,000 missions also have been linked to one base image itself. That means for all that 1,000 desktops also, the OS image or maybe the delta disk, sorry, that base disk is same. And on top of that, only one 16 MB file and zero size differential disk is getting created. And once the user log in and once the user stores the data, all the data is going to store in the differential disk. But why at the time of creation, a zero size differential disk is getting created. A zero size differential disk is getting created. This kind of linked clone technology, like MCS using, PVS is using streaming capabilities. Okay, so that's we have in the PVS sessions. Okay, so now MCS is using linked clone kind of capabilities. PVS is using streaming kind of capabilities. Okay, so then storage wise, by using that kind of linked clone, we don't have a 100 into or 1000 into 80 GB of the master image disk, only one master image, that is reducing 80% of your storage cost can be reduced. And image management wise also, single image management, okay, update, rollbacks, all these also single image. Okay, then here we have the delta kind of technology, and the delta also can be cleaned up with the pooled kind of catalogs. So that's also we have the advantage. 1,000 desktops or 2,000 desktops also, if you have the hosting infrastructure like hypervisor, computing, all those, okay, so very fastly we can scale up those also. Scalability also. So assume I want to create 1,000 desktops, 2,000 desktops, those also we can create very fastly. Only for the first base image, that copy itself will take time. Remaining all are going to happen very fastly. Okay, and it supports the multi like hypervisors, and even multi cloud also is supported. And mainly here we have two types of deployment types. One is persistent, second one is non-persistent. In the persistent, we are going to use dedicated catalogs. In the non-persistent, we are going to give pooled kind of catalogs. In the pooled, again, we have two types. What are those? Again, in the pooled, we have two types. What are those? So pooled static and
Random.
pooled static and pooled random. What is the difference between pooled static and pooled random? What is the difference between pooled static and pooled random?
Like static desktop will be assigned to a user if he got the desktop assigned from a static one. If it's a random, every time user tries to log in, whatever the
Yeah, say
available
who will
desktops
take
will.
that, controller will take that decision which desktop is there, that is going to give. But with the pool static, for the first time user entitlement is going to happen. That bonding is going to be stored in, that bonding is going to stored in the database, and from the second time onwards, based on that which of the desktop has been already assigned to the user, the same desktop is going to be given to the users. The same desktop is going to be given to the users. Okay, so then another beauty of the MCS is power management. Okay, so what is that concept of the power management is you no need to manage the power. Okay, so I'll tell one use case say suppose if I go for the if I go for this like physical catalogs. Okay, I don't get power management. Okay, so what is that? I want to automatically power on those missions. Okay, so mostly we'll get unmanaged power kind of things for those physical or PVS kind of catalogs. But MCS catalogs, we can manage the power management also. That means at morning 10 o'clock in my catalog, I want 40 missions should be power on. Okay, why at 9 to 10 I'm keeping 40 missions is most of the people will comes to the office at that moment. Okay, then after 12, okay, 10 to 12 or maybe 9 to 12, I'm keeping 40 missions. 10 to 3, most of the people won't come to the office. Then I'm keeping only 10 missions are at the power on state. Okay, those are for the new connections are waiting. Okay, so like this here, I can schedule also how many missions should be power on, power off. So these all we can automatically manage it through the power management. So who is controlling the power on the VMs? Your MCS itself is managing. Okay, so that kind of power management also. Once we create the MCS catalogs, we'll discuss this power management also. We can automatically power on, power off those VMs. You no need to go to vCenter or GenCenter to manage this. MCS itself is controlling those. Okay, so then here anyhow, so like here workflow is create the master image, snapshot, create the catalogs, then updates or rollbacks also, maintenance also we can take care. Okay, as we discussed the advantage, unified management, single instance management that lead for simplified management of the VDS to the administrators. And like with the very less infrastructure, we can create all these. Okay, after this, storage wise also we have a lot of advantages with the storage wise. Okay, then deployments also are going to happen very fastly and it supports both the persistent and non-persistent. Streaming and mission catalogs, MCS, all are supported. Okay, so then here we have some storage, quick rapid VM provisioning, multiple hypervisors, scalability, okay, non-persistent and persistent desktops, updates also like easy to roll out to the newer versions. If you have any problem, you can roll back also. So now, say here we have some disadvantages. Most of these disadvantages not with the normal desktops. Okay, so we are comparing between PVS and MCS. So with the MCS, sometimes some performance bottlenecks are there compared to PVS. In the large scale, very large scale environment, that means I have more than 2000 or 4000 desktops, then PVS have some advantages compared to MCS with the performance wise and the storage wise and on the snapshot, all these management. Okay, then in the multiple storage locations, that means you have the multiple load distribution, that's at the hypervisor level we can manage. And Citrix dependency means studio, anyhow those are required. Okay, so PVS having more benefits compared to MCS in the large scale environment, but in the smaller medium environment, MCS is the MCS uh, is the best solution. Some latency issues are there, some storage wise also, more storage, more hypervisor resources have been consumed compared to compared to PVS. Say streaming the operating system over the network, which can be beneficial for large scale. But for the small scale, PVS is very like a complex kind of thing. Which is simple, PVS or MCS? Which is simple?
MCS.
MCS is very simple kind of thing. Okay, say whatever that like maybe overflow to RAM, some of the storage kind of benefits. Now, Citrix is trying to implement even with the MCS. But PVS wise, MCS is very easier to set up. Okay, so just we need to create the mission catalog, one master image, and the remaining all MCS will take care. But PVS, we require PVS again, a separate PVS form is required. PVS high availability we need to take care, and VDisk updates, all that little complex compared to MCS. So, but we are projecting we can do both. Okay, compared to MCS, PVS is little complex. Okay, so that is the reason for the smaller medium enterprises where we have less than 2000 desktops, MCS is the best one. And we can give both non-persistent, persistent can be given. And if you want to integrate with any of the cloud also, then better to go for MCS. Whereas PVS have the physical missions, those also I want to manage single image management. That's not possible with MCS. It's possible with PVS. Physical image, single instance kind of management is not possible by MCS. Only hypervisors or cloud base is supported. Okay, so then say MCS uses linked clone kind of technology for automation. PVS uses streaming kind of technology. Okay, so now here MCS creates full clones or linked clones from a single master image and provision multiple virtual missions from that image. Okay, so these things operate from that own mission. Okay, so here disk-based cloning or linked clone from the master image. Okay, so here, whereas PVS uses streaming kind of over the network, all that images are booting, VDisk are booting. It's called as streaming kind of technology, network-based streaming of OS and apps. Okay, for the large, complex, and stateless desktop environment, that means it's non-persistent kind of things we can give. Okay, main advantage is high scalability. If you have more than 2000 kind of desktops, more storage efficiency will come compared to MCS. But for PVS, we require more networking kind of network wise. We shouldn't have any latency. Okay, but disadvantage is it's little complex compared to MCS, and we require very good networking also. So based on the client requirements, we need to suggest them either PVS or MCS. PVS or MCS. Okay. So which delivers more performance, MCS or PVS? If the networking is very good in your office, PVS delivers very high experience because it consumes less hypervisors, less storage. Okay. So but in small environments, MCS is good. Scalability wise, both are like MCS also for small and medium enterprises, easy to scale, but it consumes more hosting infrastructure compared to PVS. Management wise, PVS is little complex, whereas MCS is simple. Storage wise, okay, PVS is say MCS also will reduce storage, but PVS is extremely efficient in that also. Flexibility, again, MCS is flexible. Cost, like in the small environments, MC
Your voice is not getting.
Sir, your voice is not audible, sir.
Hello?
Yeah, it's audible, sir.
Okay. So now here, whenever we are creating this, we have the insertion disk. Identity insertion disk itself, we all use base disk. Okay. So then, like here, we have identity disk and differential disk. Okay. So then, all the differential disk, what is going to happen? If the user log off, that is going to be deleted. So these all deep level will discuss how these infrastructure, all these are going to store. So for this, what we required is, so we have already controller is there. Okay. So then we need to install hypervisor. Okay. So that hypervisor, either VMware or Citrix. So Citrix means Citrix hypervisor or GenSource. VMware means ESXi server or Hyper-V. Any of these have been supported by the Citrix, or we can use AWS or Azure also. So from this, we are going to create a mission catalog. That means not your VDA shouldn't be on the VMware workstation. Okay, it should be on the hypervisor. Then on top of that, we are going to deliver the desktops. On top of that, we are going to deliver the desktops by creating the catalogs. In the real time also, we don't use the physical catalogs. Maybe we have the legacy desktops are already there, or servers are there. Those remote connection we are giving using Citrix for the physical catalogs. But the more benefits of the VDA will come from either PVS or MCS. So for this, we required the hypervisor setup. So how to capture this hypervisor setup, we'll discuss in the next sessions. Okay, it's a comparison between PVS and MCS. Okay, and how the MCS is going to create the resources. And if any of the catalogs are not creating through MCS or those are not delivering also, we need to discuss. And tomorrow we'll discuss more on unregistered issues. So mostly we have the unregistered issue is the very common problem. Okay, so that how to troubleshoot those unregistered issues also we'll discuss. Okay, so meanwhile, the port numbers, services, enumeration process, so those all just go through once from the interview wise. Okay?
Okay.
Yeah.
Okay, sir.